Hello everyone, welcome to the course of satellite communications. In today's class, we are going to learn about satellite orbits. Okay, we have already seen the concept of satellites and different types of satellites. So in today's topic, we are going to see what are these orbits, okay, and how many types of orbits are there. So firstly, an orbit is the gravitationally curved path of an object around a point in space. Okay, so there are so many objects in the space. Okay, so whenever a path is created around that particular object, okay, and this satellite moves in the path of around that particular object, that part can be considered as our orbit. Okay, now let us say, for example, the orbit of a plane around the center of the sun in which the earth revolves. Okay, so earth moves around the sun, right? Okay, so the path in which the earth revolves around the sun can be considered as orbits. Similarly, these satellites move around the earth, okay, in the orbital space. So that we can simply say that a curved path, okay, in which the satellite moves, all the satellite moves around the earth, that particular curved path can be considered as an orbit. Okay, so there are several types of orbit. The first one is low earth orbit, second one is the medium earth orbit, third one is geostationary earth orbit, fourth is polar orbit, and fifth is inclined orbit. Okay, low earth orbit can be called as LEO, medium earth orbit can be called as MEO, and geostationary earth orbit can be called as GEO. Okay, so let's see what all these five orbits, okay, features are. Okay, so the path which is very close to the earth can be considered as low earth orbit, LEO. So LEO orbit satellites are very much closer to the earth than GEO satellites. Okay, so the distance of the LEO satellite is 500 kilometers to 1500 kilometers above the earth's surface. Okay, so LEO satellite don't stay in the fixed position. Okay, so they will be keep on moving, and they will be visible for every 15 to 20 minutes of each round around the earth. Okay, so very much closer. Orbit is nothing but LEO orbit, low earth orbit. Okay, that's why it is named as low earth orbit. The distance between the this particular LEO orbit as well as the earth is up to 500 kilometers to 1500 kilometers, and for each round, okay, if at all it need to be visible, okay, it takes around 15 to 20 minutes. Okay, and the main advantages of LEO satellite is the proximity. The LEO satellite proximity to earth is more compared to the GEO satellite, okay, which leads to better signal strength. Okay, so the main advantage of LEO is, as it is very near to the earth, okay, it gives better signal strength. Okay, and as it is very near to the earth, we can have a better point to point communication. Okay, now coming to the disadvantages, the network of LEO satellites which is needed, okay, can be very costly, and LEO satellites have to compensate for the Doppler shift caused by their relative movements. So whenever these satellites are moving with respect to time, okay, the frequency keeps on changing due to some several effects. Okay, so this can be considered as our Doppler shift, and it need to compensate Doppler shift, okay, which is caused by its relative movements. Okay, there will be a lot of atmospheric drags. As it is very nearer to the earth, it experiences lot of atmospheric drags. Okay, and which causes gradual orbital deterioration. Okay, which means it tries to move towards the earth, okay, coming out of this particular orbital space due to the gravitational force applied by this particular earth. Okay, now coming to the second one, medium Earth orbit. We can also call it as MEO. The distance of MEO satellite is around 8,000 to 18,000 kilometers from the Earth's surface. And these satellites are visible for every 2 to 8 hours. And MEO satellites have larger coverage compared to LEO satellites. As the MEO satellites are a little bit far away from the LEO satellites, they can cover a larger area of this globe, particular globe. Okay. So this is majorly used in global communication like emails, fax, etc. Okay. So compared to LEO satellites, LEO satellite orbits, MEO satellites orbits or the MEO satellites will be having weaker signal strength. Okay. So coming to the third one, geostationary orbit, it plays a major role in today's technology. This is mainly used for our communication system. So the distance between the orbit above the Earth's surface is almost like 35,786 kilometers. Okay. So the satellites present in this particular geostationary orbit revolve around the Earth at the same speed as the Earth rotates. As it need to cover the whole Earth, okay, and it need to communicate with the whole globe, okay, the speed of this particular movement of satellite is almost same speed as how this particular Earth rotates, okay. So based on this, it completes one revolution by 24 hours, okay. And one more thing, it will be having a larger coverage area, okay, and it will be used as a global coverage like TV as well as radio. Okay. Here, even though it experiences Doppler shift, that Doppler shift is negligible. Okay. And the main purpose of using a geostationary Earth orbit is communication satellites. Okay. And these communication satellites are present in this particular geostationary Earth orbit. Okay. So if at all any three satellites placed in the geostationary Earth orbit within 120 degrees apart can cover the whole world. Okay. So as this is the far away orbit from the Earth station, I mean Earth, it can cover almost the whole globe. The coverage will be huge, and that is why it is mainly used for communication purpose. That's why communication satellites are placed in this particular area. Okay. And at least if three satellites are placed in the geostationary Earth orbit with 120 degrees can cover the whole world. Okay. Coming to the polar orbits. So if you see the globe over here, so we have these particular poles, right? North pole as well as South pole. Okay. So these orbits have an inclination of 90 degrees, and these satellites take at least 12 hours to complete one rotation. Okay. And polar satellites mostly passes above or nearly above both the poles of Earth. Okay. We have two poles, right? North pole as well as South pole. Okay. Satellites which are near or passing through the particular poles, North pole or South pole, those particular paths can be considered as our, okay, polar orbits. Okay. So polar satellite passes above or nearly above both poles of Earth. Okay. So, and these satellites take at least 12 hours to complete one rotation, and they will be having a nearly inclination of 90 degrees. And coming to the last one, inclined orbit. Okay. If you see here, the inclined orbit, there is an angle forming around the globe or the Earth. Okay. So a satellite is said to be inclined around the Earth if the orbit exhibits an angle other than 0 degrees to the equatorial plane. Suppose this is an equator, right? Okay. So apart from the equator or 0 degrees, okay, if at all any orbit makes an angle like this, okay, apart from the equator, if at all any orbit makes an angle, okay, so that orbit can be considered as the inclined orbit. Okay. So this is the last one, orbit space, where orbit is nothing but the space around any object, okay, or path around any object in the space, which helps the satellites to move around. Okay. So these are the overview of an satellite orbits.